16.4.1 reads, you are standing 7 meters from a sound source that radiates equally in all directions, but it is too loud for you. Okay, 7 meters is a magic number. How far away from the source should you stand to experience 1/3 the intensity that you did at 7 meters? Okay, this problem uses the only equation we're going to kind of use in chapter 16 here, and it's the sound intensity equation. So it's a fourth equation we should add to our toolbox. Let's go ahead and add that in if you didn't do that yet. So if you have your note card of equations, let's go ahead and add that in really. So in our toolbox, we actually have 3 equations, and then we have a fact for the speed of sound and the speed of light. Okay, so our 5th equation, it's not really an equation, it's just a 5th tool we're going to add. Okay, or this is an equation, but this is the speed of sound in air and the speed of light in radio waves. But we're going to add our 4th one here, and that is looking at what's called the intensity of sound. The intensity of sound is simply equal to the amount of power coming from the sound source in watts divided by 4 pi r squared. Okay, so this looks weird, but let's look at the units. Intensity is measured in watts per square meter. Okay, how much energy in a sound wave depends on how much power you put in, how many watts you have in your speaker or your headphones, or if you have a musician performing. And then 4 pi r squared, r is the radius you are from that sound source in meters, and then it's squared because the sound spreads out in all directions. Anybody recognize 4 pi r squared? It's the equation for, yeah, okay, I'm going to try and draw in 3D, but I'm not very good. It's the equation for a sphere, surface area of a sphere, okay, as it passes through a certain area there, okay? That's how much sound energy is spreading through. They're kind of like a ripple in a pond, but we're spreading out in 3D there, okay? Tricky. So back to our problem. Step 1, we want to make a little what? A little sketch, okay? So you're in a concert hall, there's a speaker here, okay? And it sends out sound waves in all directions in 3D, okay? And that's why you see that 4 pi r squared equation there, okay? Step 2, we're just going to list our information. The only thing they tell us is that what? At first, you are 7 meters away. 7 meters is a measure of your radial distance, okay? So you're standing right here, and at first, you're 7 meters away, okay? And they don't tell you the power rating of the speaker, and they don't tell you the intensity of the sound, okay, in watts per square meter. But that's okay. What do they tell you is you want to hear the sound louder or more softly? Yeah, so use common sense. You want to move closer to the speaker or further away? You want to move further away, okay? But how much further away, okay? Now there's 2 ways we could do this. We could do this using a lot of math, okay? The power of the speaker is the same, so it's actually P1, and the intensity of the sound is going to be 1/3 the intensity originally. We could do this with a lot of math by setting up ratios, but how about we do this conceptually? Is that okay with you guys? We're going to do this in a little conceptual approach here. Okay, because this one we could do a lot of plugging and chugging, but here's the basic idea. If the intensity of sound is equal to power over 4 pi r squared, what we're really changing in this problem is the what? The wattage of the speaker or our distance. Yeah, our distance away, right? Okay. So what we're changing here, in order to make the intensity less, okay, we have to move further away. And intensity is proportional to 1 over the radius or distance squared. This is proportional. So here's what's weird. Okay, if you are at a rock concert, rock on, and you're in the front row, okay, and then your friend is like 10 rows back, is it 10 times softer to them? No, it's exponential because the sound spreads out in 3D in all directions, and it goes like in a 3D spherical cone, or not cone, sphere rather, like a water, like a rock you drop in a pond. Okay, that sound has to spread out in 3D so that it goes through the surface area of a sphere. Think of it that way, right? So it becomes 1 over r squared is the relationship. So what's 10 squared? 10 squared is what? 100. So it's actually 100 times less sound energy if you're 10 rows back. Okay? So remember how I said in this class we got to use a little math, but I want you to get a big idea out of understanding how waves work in sound. The big idea is when you listen to music, not only does it matter how loud you set the decibel setting for your headphones, but distance also makes a difference too. So those of you that like your music loud, if you're in the front row of a concert and you're 10 times closer than your friend behind you, you're not trashing your ears 10 times more. What's 10 squared? 100. Okay, so here's what's weird. In this problem, you want your sound to be 1/3 the loudness, right? Is a way to think of it. Okay, compared to 1 over r squared, right? In terms of the loudness of the sound there, yeah? In terms of the intensity, 1/3 the intensity. So if we want to solve for what this new r squared is going to be, let's bring it on top there, okay? By expressing it this way there, okay? That we're going to flip our little ratio here, okay? We want it to be, scroll up? Yeah, no problem, I can scroll this up here. We're going to flip our proportional equation because everything's on the bottom. We'll just cross multiply or whatever. We're going to flip it all on top there, right? Okay? But what we really want to know is what's our new distance. So we know we have to stand further away, but is it going to be 3 times further? It's not, right? Because it's an exponential relationship. So in other words, another way to look at this here is to get r by itself, what do I got to do to both sides? Take the what of both sides? I'm going to take the square root of 3. Okay? I have to stand the square root of 3 times further away. Okay? Is a way to look at it conceptually. So now, if I go ahead and get out my calculator here, we're going to go ahead and take the square root of 3. Okay? And then what was our original distance? We were how many meters away? 7. Okay? I have to stand the square root of 3 times 7 further away. So it's not 3 times further away. It's the square root of 3, which is, I can't do it in my head. What's the square root of 3? Help me out here. Anyone do that in their head? Nah, we're not like that, right? It's like 1.7 times further away, or 12.12 meters. Okay? So my new radius should be about 12 meters away. Okay? 12.12. Actually, I guess if we're supposed to do sig figs, I'd have to look at the original problem, but like 12 meters is probably what you'd round it to. Okay? Something like that. And that's pretty much how you do it. Okay? If you want to see it more mathematically done, I can express it as a ratio of 2 equations. You guys want to see that? Okay, I was helping somebody yesterday after school, and I did that way, and I think I freaked them out. So I'd rather do it more conceptually. Okay?